how do we find probabilities in a normal distribution? So here, if you have a probability distribution for x that is normal, then you want the probability that x is between a and b, then this area is the probability of x being between a and b. Okay, since area is the probability, then x being equal to exactly a particular value is always 0. Like if you say probability, what is the probability of x equal to a in a normal distribution? So that will be 0. What is the probability that x is equal to b, a particular value? And that is 0. But if you say what is the probability that x falls anywhere between a and b, then we find the area under the curve like this, and that will be the probability. And this area under the curve is what is tabulated in the normal distribution table. Now, one more thing that we need to observe is, since normal distribution is symmetric, the probabilities are equally distributed. So mu is being at the center, the probability on the right side of the mean and probability on the left side of the mean are equally divided, which means it's 50%, 50%. And similarly, any area to the right, the probability is exactly same as the similar area to the left. Okay, and here in standardized normal distribution, what is the probability that z is less than 2? So the area here, z is less than 2. Again, you can get this from the normal distribution table. So here is the normal distribution table. Now z equal to 2. So that this is the area that is tabulated, the cumulative area. So z goes from minus 6.0 all the way to 6.999. Now if you want z equal to 2, which is right here, 0.9772, that's the probability listed here. Now probability that x is between a and b, again you convert a into z, convert b into z, so you'll have two z's, and then you use the standardized normal table with those z's instead of x's. So here, find probability of x less than or equal to 18.6, with mean is 18, standard deviation is 5. So first step is to convert x into z. So for 18.6 minus 18 divided by 5 gives you 0.12. So which means x of 18.6 with mean of 18 and standard deviation of 5 is the same as z of 0.12. So this probability for x less than or equal to 18.6 is the same as the probability z less than or equal to 0.12. Now we can go to the table and read the probability below z equal z 0.12. So we go to the table and we want z of 0.12. So here z of 0.1 and 0.12 is the second decimal is given here in the in columns. So you get 0.5478. So that's what you have here. So that 0.5478 is the probability that z is less than 0.12, which is the same as probability x less than 18.6. So this is how you would use the conversion from x to z and then use z in the normal table. Okay? Now if you want to find the probability x greater than 18.6, then it is not sufficient to simply go to the table. So you get the probability that you get from the table is the cumulative probability. So if you want the opposite, then you have to go 1 minus the cumulative probability that you get from the normal table. So normal table is not always the answer. Normal table is part of the way. That's one step in the process of finding the final probability. So sometimes what you read from the normal table is the final answer. But sometimes you have to take that value from the table and then do some more computation to find the final answer. So you have to be very careful with this. Okay. So if this is probability of z less than 0.12, which is 0.5478, probability that x is greater than 18.6 will be 1 minus that probability. Now suppose x is normal with mean of 18, standard deviation of 5, and we want the probability like this, 18 to 18.6, something like this. Now 18 is Z is 0 because 18 minus 18 Z gets Z is 0. 18.6 Z is 0.12. So now you get two table areas. Table area for Z equal to 0. So Z equal to 0 is 0.5. Z equal to 0.12 is 0.5478. So we need to find the difference between those two then. So 0.5 and 0.547. So this is 0.5 and all of that is 0.5478. So the balance 0.5478 minus 0.5 gives you 0.0478. So here you had to get two values from the normal table and then subtract one from the other. So every time it's a good idea to draw a normal table and picture the area that we want, and that will make it easier to do the computation correctly. So suppose that X is normal with the mean of 18, standard deviation 5. Suppose if this is the probability we want, 17.4 to 18. So 18 is the mean, so we know the area there is 0.5. For 17.4, you have to convert that 17.4 to Z first, which is minus 0.12. Then you go and read for minus 0.12 what the area is. So here minus 0.12. 0.12 is here. 0.12 is 0.4522. Okay. So 0.5 minus 0.4522 gives a balance of 0.048 for the probability that we want.